Imagine a star that never dies. A celestial beacon that has been shining since the dawn of time and will continue to glow long after the last galaxies fade into darkness. Scientists believe that all stars must eventually burn out. But what if some don't? What if certain stars break the rules of time itself? Across the universe, astronomers have discovered mysterious anomalies, stars that seem far too old, stars that shine with unexplained energy, and stars that should have died long ago but refuse to fade. Could these be cosmic immortals? Could there be stars older than the universe itself? In this journey through the cosmos, we'll explore 10 strange and fascinating types of stars that might live forever, stars that could outlast time itself. Let's begin. HD 140283, nicknamed Methuselah, is one of the strangest stars in the universe. When astronomers studied this seemingly ordinary subgiant, they found something impossible. It appears to be older than the universe itself. The universe is 13.8 billion years old, according to the standard cosmological model, but calculations for Methuselah's age suggest it's 14.46 billion years old, which shouldn't be possible. This raises one of the greatest paradoxes in astronomy. How can a star be older than the cosmos that contains it? There are several possible explanations. The first is measurement error. Perhaps our understanding of stellar evolution isn't precise enough, and our age estimate is slightly off. A small adjustment in our models could make Methuselah fit within the timeline of the universe. But another possibility is that our universe is not the first. Some physicists propose that the cosmos undergoes cycles of destruction and rebirth, with each universe leaving behind traces of its existence in the next. If that's true, could Methuselah be a remnant from a previous universe, surviving through cosmic rebirth? Or perhaps there's something even stranger, an unknown mechanism that allows stars to persist across time itself, challenging everything we know about stellar life cycles. If we find more stars like Methuselah, we may have to rewrite the entire history of the cosmos. When most stars die, they explode in spectacular fashion, scattering their elements into space. But some don't simply vanish, they linger, glowing with the faint embers of their former selves. These are white dwarfs, the dense cores left behind after a star like our Sun burns through its fuel. White dwarfs don't produce energy through fusion like normal stars. Instead, they shine because of residual heat, cooling incredibly slowly over billions of years. But here's the mystery: they may never fully fade away. In theory, a white dwarf should eventually become a black dwarf, a frozen, invisible corpse of a star. But here's the catch: the universe isn't old enough for a single black dwarf to exist yet. White dwarfs take trillions of years to cool completely, meaning every white dwarf ever formed is still glowing today. This leads to an eerie thought. These stellar ghosts could outlive every galaxy in the cosmos. Long after stars stop forming and galaxies dissolve into nothingness, these ancient remnants will continue to radiate their final energy into the void. Some theories even suggest that white dwarfs could reignite, turning into something called a black dwarf supernova, a type of explosion that has never been observed but may happen in the incomprehensibly distant future. If true, it means that the last fireworks of the cosmos won't come from galaxies or nebulae, but from these undead stars, refusing to fade into oblivion. Could it be that some white dwarves will never stop glowing? Could they find a way to survive beyond even the heat death of the universe? One thing is certain: long after the last galaxies fade, white dwarfs will remain, tiny flickers of light in an eternal darkness. Imagine a star so dense that a teaspoon of its material would weigh as much as a mountain. A star so indestructible that it might persist for trillions of years, far beyond the death of normal stars. These are neutron stars, the ultra-compressed remnants of supernova explosions. But here's where the mystery deepens. Some neutron stars, particularly pulsars, seem to follow patterns too precise to be natural. They emit electromagnetic pulses so regular, so rhythmic, that when the first pulsar was discovered, astronomers seriously considered the possibility that it was an alien beacon. And then there's another enigma: magnetars. These are neutron stars with magnetic fields a quadrillion times stronger than Earth's, capable of warping space and time itself. Magnetars unleash powerful bursts of energy that defy explanation, some so intense they have been detected across galaxies. What's feeding these ancient stars? Could they be tapping into some hidden energy source? Even more mysteriously, neutron stars seem too stable for their own good. According to physics, they should eventually collapse into black holes as they lose energy. But many neutron stars show no signs of slowing down, spinning at near-light speeds for millions or even billions of years. Here's where speculation begins. What if neutron stars are more than just dead remnants? Could they be cosmic time capsules preserving information from past universes? Some physicists suggest that neutron stars, with their incomprehensible density, might store quantum information in a way that defies time itself. And then comes the ultimate question: could neutron stars live forever? Some theories suggest that if proton decay never happens, neutron stars might remain stable for eternity. That would make them among the last surviving objects in the universe, potentially outliving everything we know. Are neutron stars merely remnants, or could they be something more, a deeper part of the universe's ultimate mystery? What if I told you that some stars might be hiding black holes at their very hearts? A paradoxical form of stellar existence, where creation and destruction coexist. Scientists have theorized the existence of black hole stars, also called quasi-stars, which may have existed in the early universe. These weren't just ordinary stars, they were cosmic titans, reaching over 100,000 times the mass of our Sun. Inside them, rather than a fusion-powered core, was a growing black hole, consuming the very star that sustained it. But here's the mystery. Some of these black hole stars might still exist today. If one were large enough, its outer layers could keep feeding its black hole core indefinitely, preventing it from collapsing completely. This would make it one of the most bizarre and immortal objects in the universe, an eternal balance between light and darkness, between life and death. The idea challenges everything we know about stellar evolution. If such stars are real, could they still be hidden in the depths of our universe? Could they be responsible for strange gravitational anomalies we've observed? And what if some black hole stars never stop growing? If they accumulate enough mass, they could become something even more mysterious, a direct gateway to another universe. Some physicists speculate that at the center of certain black holes, space-time may fold in on itself, creating pathways to other realities. So the ultimate question remains, are there stars in the universe that will never die because they have already collapsed into something beyond our understanding? If such stars exist, they would be among the most powerful and enigmatic objects in the cosmos. Eternal beacons of a force we barely comprehend. For decades we believed that black holes were one-way tickets to oblivion. Nothing could escape them, not even light. But what if that isn't true? What if, deep inside certain black holes, something is still alive? Enter the Planck star, a radical but fascinating idea that challenges our understanding of black holes. The theory suggests that when a black hole collapses, it doesn't shrink into a singularity. Instead, at its very core, the immense gravitational pressure is counteracted by quantum forces. This prevents it from fully collapsing and instead creates a dense, compact object, a Planck star, that could one day re-emerge. If true, it means black holes aren't permanent graves for matter, but long-dormant cocoons, waiting to explode back into existence. Some models suggest that Planck stars could take trillions upon trillions of years to finally burst free, releasing all the information they once consumed. If that happens, the entire fabric of reality could be rewritten. But here's where things get even weirder. Some physicists speculate that a Planck star might not just be a reborn black hole, it could be the seed of an entirely new universe. In this scenario, black holes don't just swallow matter. They compress it and then expel it elsewhere in a new Big Bang. If this is true, then our universe itself may have been born from the death of a previous cosmos, birthed inside a Planck star from another reality. And that leads us to the biggest mystery of all. If Planck stars are real, could they be the true eternal stars of the universe? Not just existing for trillions of years, but recycling themselves across cosmic cycles, continuously fueling the birth of new universes. What if black holes aren't the end of time, but gateways to something beyond it? What if the most eternal stars in the universe aren't natural at all? What if somewhere, deep in the void, alien civilizations have already engineered artificial stars, built to last forever? We often think of stars as temporary, burning through their fuel, collapsing, and eventually dying. But what if a civilization advanced enough to manipulate entire star systems could break that cycle? Enter the Dyson star, a speculative concept that takes the famous Dyson sphere to its ultimate extreme. A Dyson sphere, as first imagined by physicist Freeman Dyson, is a megastructure built around a star, capturing nearly all of its energy output. But why stop there? What if a civilization could directly manipulate the nuclear fusion of a star, ensuring that it never runs out of fuel? In theory, a Type 2 or Type 3 civilization on the Kardashev scale could harness entire stellar systems, controlling their energy output with pinpoint precision. They could siphon hydrogen from nearby gas giants, preventing a star from dying indefinitely. Or even more bizarrely, they might create their own stars, artificially igniting them in deep space, manufacturing eternal suns that will burn for trillions of years under perfect control. Here's where the real mystery begins. Could Dyson stars already exist? Some astrophysicists have speculated that strange infrared signals we've detected from deep space could be the signatures of such megastructures. Imagine an entire civilization that has abandoned planets altogether, living around artificial stars in vast engineered habitats that outlive the galaxies themselves. And if we've already detected hints of something like this, what does it mean for the true age of the universe? Could we be looking at the remnants of civilizations older than our own cosmos? The idea is chilling. What if the oldest stars in existence weren't made by nature, but by something far beyond us? When we think of powerful, long-lasting stars, we often imagine the biggest and brightest. But the true survivors of the cosmos aren't the massive blue giants that burn out in mere millions of years. They're the smallest, dimmest stars, the red dwarfs. Red dwarfs are the most common type of star in the universe, making up nearly 80% of all stars. But what makes them truly special is their insane lifespan. Unlike our Sun, which will burn for about 10 billion years, red dwarfs can last for hundreds of billions, even trillions of years. Some estimates suggest that the smallest red dwarfs could shine for 10 trillion years or more, far longer than the current age of the universe itself. Now here's where things get eerie. If red dwarfs can outlive the universe, what does that mean for the end of time? Current models suggest that in the distant future, the universe will become a cold, dark place. Galaxies will drift apart, black holes will consume everything, and even the most powerful stars will burn out. But red dwarfs will still remain, flickering dimly in the cosmic void. Imagine a future where nearly all light has faded from existence, except for these tiny immortal embers, still stubbornly burning in the darkness. If intelligent civilizations could somehow survive this long, red dwarfs might be the last beacons of life in the entire universe. But what if there's something we're missing? Could red dwarfs have an unknown self-sustaining mechanism that allows them to last even longer than physics predicts? Could some of them be so efficient that they never truly die? And the biggest mystery of all, if red dwarfs can outlive everything, could they be the only witnesses to the final fate of the cosmos? Could they see things unfold that we can't even begin to imagine? Perhaps, in the farthest reaches of time, when the last galaxies have faded and the black holes have evaporated, a single red dwarf will remain, alone, eternal, and watching. We think we understand the universe, or at least we try to. But what if there are stars out there that we can't even see? Not because they're too dim or too far away, but because they exist in another dimension altogether. For decades, physicists have speculated about the existence of extra dimensions beyond the three we experience. String theory, one of the leading theories of everything, suggests that our universe could be just one slice of a much larger cosmic structure, like a single page in an infinite book. If that's true, then what's stopping stars from forming in these hidden dimensions? Imagine a ghost star, a celestial body that exists not in our visible cosmos, but in a parallel layer of reality. It might emit energy, but in ways we can't detect. It might exert gravitational influence, but without an obvious source. Some researchers have even suggested that these ghost stars could explain dark matter, the invisible mass that makes up 85% of the universe. But here's where it gets even stranger. What if some of the stars we see in our night sky aren't actually there? What if they're just projections, faint echoes of something existing in a dimension just beyond our reach? Could pulsars, with their bizarre rhythmic signals, be interacting with forces outside of our known universe? Could some black holes actually be gateways to these hidden realms, allowing energy to leak through from the ghost stars beyond? And the final chilling question, if ghost stars exist, could they be home to something else? If life is possible in our reality, then why not in others? Could entire civilizations be thriving around stars that we will never see, never touch, and never even know exist, watching us from the other side? If the universe is truly multidimensional, then the stars we see might be just the beginning. What if some stars aren't made of normal matter at all? What if, instead of burning through nuclear fusion like our Sun, they exist in a state of pure quantum strangeness, defying everything we know about physics? Enter the mind-bending possibility of quantum stars, hypothetical celestial objects that push the limits of what's possible. Unlike typical stars, which are bound by the laws of thermodynamics and gravity, quantum stars could exist in a delicate balance between matter and energy, behaving more like probability fields than physical objects. Some theories suggest that in the earliest moments of the universe, conditions may have allowed exotic matter to form, matter that isn't bound by normal atomic structure. Instead of being made of protons, neutrons and electrons, these objects could be composed of pure quantum fields, stabilized in a state we don't yet understand. They wouldn't burn fuel like other stars. They might not even have a clear boundary between their core and their atmosphere. They could be stars of pure probability, existing in a superposition of states, both alive and dead at the same time. But what if some quantum stars still exist today? Could certain neutron stars or white dwarfs, under the right conditions, collapse into these strange objects? Could black holes, instead of truly swallowing matter, be transforming their cores into quantum singularities, stars that exist in a limbo between space-time itself? And here's the most haunting idea. What if quantum stars are everywhere, but we simply lack the right tools to see them? Could these objects be responsible for the mysterious fast radio bursts, FRBs, we occasionally detect from deep space, signals that seem to appear and disappear with no explanation? Could they be hiding in plain sight, influencing the structure of the cosmos in ways we can't yet perceive? If quantum mechanics is the true foundation of reality, then somewhere out there, in the vastness of the void, there may be stars that flicker between existence and nothingness, forever. Imagine the end of the universe. Not just the end of Earth, the Sun, or even the Milky Way, but the end of everything. Trillions of years into the future, the last stars will flicker out, the final black holes will evaporate, the cosmos will stretch into a vast, cold and empty void where nothing new is born. But what if one star refuses to die? Astrophysicists predict that in the distant future, as the universe ages, new stars will stop forming. The remaining ones will slowly burn through their fuel, fading into white dwarfs, neutron stars and black holes. Eventually all energy will be lost, and the cosmos will enter what is known as the heat death, an era where entropy has consumed all usable energy, leaving behind nothing but a lifeless void. But recent speculative theories suggest that in rare cases, certain stars could survive beyond the heat death of the universe. How? Some possibilities push the very limits of physics, the eternal Dyson star. A hypothetical scenario where an advanced civilization builds a perfect Dyson sphere, harvesting and recycling every last bit of energy from a dying star to keep it burning indefinitely. If such a construct existed, it could theoretically outlast the rest of the universe, sustaining light in the eternal night, the star that time forgot. Some stars may enter a suspended animation state, cooling down but never fully dying. If the expansion of the universe somehow slows or reverses, a concept tied to cyclic universe theories, this could cause certain stars to pause in their evolution, leaving them in a bizarre, half-alive, half-dead state for trillions or even quadrillions of years. The phantom star. What if some stars can leak energy from another universe? If theories about extra dimensions, quantum fluctuations, or even simulation theory hold any truth, then a star could exist that is constantly refueled by an unknown source, refusing to fade even when all others are gone. Now imagine being an observer in this distant, dying universe. Imagine traveling through absolute darkness for unimaginable distances, only to stumble upon a single burning star still flickering against the impossible. A star that has seen the birth and death of galaxies, a star that has outlived black holes, a star that may never die. Could this be the final light of the cosmos? Or something even more mysterious, an impossible anomaly that defies time itself? Perhaps at the end of all things, when the last whispers of the cosmos have faded, something, somewhere, will still be watching. What if I told you that some of the stars we see in the night sky don't actually exist anymore? What if, when we look up, we are gazing at the ghosts of dead stars, their light still traveling across the cosmos long after their deaths? Because light takes time to travel, every star we observe is actually a snapshot of the past. A star 10,000 light-years away isn't shining in real time. We're seeing it as it was 10,000 years ago. That means some stars we see in the night sky have already exploded, collapsed, or vanished into the abyss, but their final light is still racing toward us. But here's where things get even weirder. What if some stars haven't just died, but have disappeared without a trace? In 2019, astronomers launched a project called VASCO, Vanishing and Appearing Sources during a century of observations, comparing old star catalogues with new ones. And they found something shocking. Hundreds of stars seem to have vanished entirely, not exploded into supernovae, not turned into black holes, but simply ceased to exist with no explanation. There are only a few known ways a star can disappear. A supernova leaves behind a neutron star or black hole, a failed supernova, where a star collapses into a black hole without an explosion. A runaway star ejected at extreme speeds, but in many cases, none of these explanations fit. The stars simply winked out of existence, sometimes in a matter of months or even weeks, something that shouldn't be possible. Could these be signs of undiscovered cosmic phenomena? Could advanced civilizations be harvesting entire stars, draining them of energy for their own use? Or are we witnessing a fundamental flaw in our understanding of reality itself? And the biggest mystery of all, could Earth's own sun one day become a ghost star, disappearing not just from existence but from history itself? The night sky is full of secrets. Some stars may still be shining long after they've died, and others may have never really existed at all. The universe is far stranger than we could ever imagine. Stars exist that should be impossible. Some may outlive time itself, and others may not be stars at all. But what do you think? Could there be eternal stars hidden beyond the limits of science? Are there secrets still waiting to be uncovered in the depths of space? Let me know your thoughts in the comments below. And if you love exploring the mysteries of the cosmos, don't forget to like, subscribe and hit that notification bell so you never miss out on the strangest, most mind-blowing discoveries about our universe. Until next time, stay curious, stay cosmic and keep looking up.